All right, let's just jump right in. This is a question that, it affects millions and millions of families. And the answer, well, it's all about being able to see the invisible. See, right now, probably the most powerful tool we have for this is something called positron emission tomography. You've probably heard of it, PET imaging.
Now, you might be thinking, wait, don't we have MRIs and CT scans? And yeah, we do, but those show us the structure of the brain, like a roadmap. A PET scan is different. It shows us the brain's function. It's like looking at a live traffic report for that map. It gives doctors this incredible window into the brain's metabolic processes so they can literally see which parts are buzzing with activity and which parts are starting to slow down. And that slowdown, that's a telltale sign of disease that other scans can just completely miss.
So, okay, we're calling it the gold standard, but let's dig into why. What is it that makes PET so special in this fight against dementia? How does it actually see the brain at work?
Well, the magic really comes down to this radioactive tracer called FDG, and you can think of it like a Trojan horse. See, your brain cells absolutely love glucose. It's their fuel. So when they see this FDG, they just slurp it up like it's regular sugar. But here's the clever part, the trick. They can't actually break it down. So it just gets trapped inside the most active cells, and that makes them light up for the PET scanner. What you get is this incredible map of brain activity, and it reveals those very specific, very telling patterns of decline that are so typical of Alzheimer's.
Okay, so if this tech is so great, if it's the gold standard, you've got to be wondering, why isn't this the very first thing doctors do for anyone with memory concerns? And that's the right question. The answer points to this huge bottleneck in the system. The best tool we have for the job is, believe it or not, often completely out of reach.
And to really get why, let's look at the heart of the problem. We're going to lean on the expertise of Professor Alfred Buck here. He's a neuroimaging expert who's been working with this technology for decades, so he's seen it all.
You see, the PET scanners you find in hospitals today, they weren't really designed for brains. They are massive, multi-million-dollar beasts built for scanning the whole body, mainly for cancer patients. So what does that mean? It means they are wildly expensive, they need these huge, complex rooms, and their schedules are just jam-packed. This ends up pushing crucial brain research and even clinical brain scans to the nights, to the weekends, if they can even happen at all.
And as Professor Buck points out, even that weekend research option is pretty much gone now because of tighter regulations. It's just a classic case of logistical gridlock, and it's squeezing out the very neuroscience that this tool was so perfect for. So how did we even get to this point? How did a tool that started out being perfect for the brain get, hijacked for everything else?
Well, the answer is pretty fascinating, and it all comes down to how the technology evolved. It started out as a very, very different kind of machine.
So before the 2000s, PET was really this niche research tool. It had a tiny field of view, which honestly was perfect for looking at a single slice of the brain. But then came the game changer. Engineers figured out how to combine PET with CT scanners. And this was huge. It cut whole body scan times from like an hour down to under 20 minutes. And just like that, the demand from cancer doctors, oncology, it just exploded. The technology boomed, but in the process, it kind of forgot where it came from. It left its brain-focused roots way behind. So what we ended up with was this incredibly powerful, life-saving machine that was perfectly tuned for finding cancer anywhere in the body. But it became total overkill for just looking at the brain. Which, finally, brings us to a really elegant solution.
So what if we could take everything we've learned, all the amazing advances in modern tech, and circle back to that original idea? What if we built a device for one purpose and one purpose only, imaging the human brain?
And this just lays it out so clearly. You've got today's reality, the whole body scanner that's massive, costs millions, and is always overbooked. And then you have the dedicated solution, a brain scanner that's so much cheaper, small enough to fit in a regular room, and built just for neuroscience. The biggest takeaway here is just plain and simple availability. This would finally open up the schedule for patients and researchers who need it the most. And look, the idea here isn't to get rid of those big, powerful whole-body scanners. They're still incredibly important. The idea is that these smaller, dedicated devices can work right alongside them. So you can imagine a PET center with its big machine humming along for oncology, and right next to it, a smaller, super efficient one that's finally giving brain health the focused attention it's deserved all along. So let's bring this back to the real world. What does all this talk of increased access actually mean for someone, for you or a loved one, walking into a doctor's office with memory concerns? This isn't just a small improvement we're talking about. This could completely revolutionize the entire diagnostic path for dementia.
Professor Buck lays out this really clear three-step process. Okay, step 1. It starts with a simple, cheap blood test that screens for those toxic proteins we associate with Alzheimer's. Step 2. If that test comes back positive, you move on to a quick, easy-to-get brain PET scan to confirm it and make sure it's not a false positive. And then, step 3, with that solid confirmation in hand, doctors can start targeted treatments way, way earlier than we can today.
And this right here, this is why the timeline is so absolutely critical. We know that the destructive proteins that cause Alzheimer's can be building up in the brain for decades, literally decades, before the very first symptom of memory loss shows up. And the implication of that is just staggering. If we could make screening routine for everyone over, say, 50 or 60, we might actually be able to find and treat the disease before it ever gets a chance to take hold.
And you know what? The impact here is so much bigger than just Alzheimer's. Unlocking real access to brain PET scans, it just opens up a whole new world of possibilities for all kinds of conditions.
I mean, think about it. This technology is a critical tool for understanding and diagnosing a whole range of brain disorders. We're talking about things like epilepsy, Parkinson's, brain tumors, the after effects of a stroke, the list goes on. Making this more accessible isn't just a win for patients in the clinic. It's a massive catalyst for research across the entire field of neuroscience.
At the end of the day, the ultimate goal, and you hear this from the pioneers who are building these new scanners, it's all about democratizing the technology. It's about taking this incredibly powerful tool that's been locked away inside these giant, expensive machines and finally putting it into the hands of more doctors and more researchers all around the world. That's the real impact here. That's why this matters so much.
So look, making a powerful tool like this accessible, that's the first massive step. But it leaves us with a really exciting question to think about. Once we can actually see these diseases clearly and super early, what's next? The next great frontier has to be figuring out what we do with all that incredible knowledge and how we finally learn to stop these conditions right in their tracks.